any job for us, yeah. But pressure drop across the bit, across the middle, do the job for us. We can use this energy to drive, to drill. Look at this is the system, yeah. We are pumping. It's a flat pump, yeah. It goes to the gooseneck or the standpipe, then to the swivel or the top drive, Kelly, or if not Kelly, the drill pipe. Inside the drill strings, go to the bit, and then through the annulus, and go to the shaker. And we have, for example, tube tanks, suction tank, mid tanks, and the process. Okay, for the same picture, the surface, there is some equation for that. Usually we take it, 50 psi to 100 psi. But for the American rig, there is an arrangement. Also for the Chinese type, there is an equation for that. We can calculate. But usually we have 50 to 100 psi pressure drop in the surface equipment. Which is, if you look at here, this surface pressure drop is a function of density, mud weight, yeah, Q, rate, is a gallon per minute, E, which is a constant, depending on the type of the surface equipment. For the American Western rig, there's a 4E, yeah, depending on the type of the power of the rig, you have a different arrangement. And the plastic viscosity, we can calculate P1. We will do example and we will use it. Look at here. If, for example, this is for the E, we have 4 types of equipment, and we have 4 constant for them, which is depends on the surface equipment type. We will choose one of them and do the calculation. This is a metric unit, and this is the empirical units. Okay, it's a pipe and annular. Pipe and annular pressure loss. As I told you, we call it the parasitic pressure loss. These are not doing any job for us. This is one of the limitations. If you look at, the reason we cannot continue for drilling for very deep, one of them is hydraulic. There is 3 parameters that limit us to go further. The rig capacity, it means the mass strength. Second is the drill string strength. And third is the hydraulics. For example, our pump may be 3,000 psi or 5,000 psi. Yeah? This looks like this in the industry. We cannot, for example, more than 90% or 80% of the maximum allowable pump pressure. When we reach to this one, it stop us to go further. Yeah. This hydraulic pressure loss is a function of flow rate. More flow rate, more pressure loss. About the dimensions, yeah, inside diameter, the ID, OD. And also the mud rheological properties. What is the mud weight? We are pumping, 20 ppg mud weight, very heavy, or we are pumping like water or brine. Plastic viscosity, and also the yield point. That's why this is the plastic viscosity. You should control it, not exceed. Yeah. There is a problem. Yeah, during the drilling, you have a contamination. The clay is added, and effect on the plastic viscosity. I believe in the drilling engineering, in the drilling operation, the most, this mud engineer has played a very important role. A good mud engineer will survive the operations. Sometimes, they do not appreciate properly. I don't know why industry do not pay as a low payment respect, for example, to directional driller, to the supervisor. But the role of mud engineer, a good mud engineer will save the operations if they can control and react properly with a good mud weight, with the treatment. And the types of the flow, okay? Sometimes it depends on the geometry and the site. We have a laminar flow or tubular flow. These are all effect on the hydraulic pressure losses. You can see, the pressure drop across at the beat. More velocity, more pressure drop. Yeah, it's a blue. For example, the scale is meter per second. Yeah, you can see where is the blue is the low velocity, and go to the green, yellow, and red. It's gonna be higher velocity. For sure, in the nozzle, yeah, around the nozzle we have a higher velocity, maybe more velocity that you're gonna do they call it like impact force or jet impact force for us, helping to clean the bottom of hole. For the bit pressure loss, Okay, this bit pressure drops mainly for the cleaning and cooling. When we are not very deep, or it is not high pressure, high temperature, we have a jet nozzle. But when we go deeper and deeper, sometimes cleaning is not important. Cooling is important. That's why you have a water course, like in the diamond bit, impregnated bit. We eliminate the nozzle and create the water course. We'll discuss this part in the bit section tomorrow. Yeah? But the hose is important for us. Cleaning, because we don't want to generate the cutting and regrind it. Yeah? We want to generate the cutting and transport it to the surface. Always we want to touch the rock new face. Yeah? That's how we can reach to this point with the enough hydraulics. Yeah? The cutting is generated, need to transport to the surface as quickly as possible. And also the cooling. Here with the rock pressure in the soft formation, yeah? We have three power for the drilling. Weight on the bit, torque at the bit, and the hydraulic. If it is soft, we can drill with the